So guys, in our previous video we saw that what do you mean by adsorption, and we came to the conclusion that adsorption is a phenomenon where the liquid or the gas molecules are getting accumulated on the surface of your solid. Alva? So mainly in our overall words we can just say that whatever our adsorption was there, it's a surface phenomenon and it is majorly a spontaneous process. In today's video, we are mainly going to discuss about the types of your adsorption. What is that? Types of adsorption. Basically, the two important types we are going to see. One is called as physical adsorption, or it is also called as physisorption. Yes. Similarly, another type we are going to see, which is called as that of your chemical adsorption, or it is also called as chemisorption. Yes, these are the important two types we are going to see under the category which falls of your adsorption. So basically the main difference between the two we are going to study is about what type of the bonding, mark my words, what type of the bonding is existing between the adsorbate and the adsorbent. Okay, ಇವೆರಡು ತರದ adsorption types ಅಲ್ಲಿ ನಾವೇನ್ ಮುಖ್ಯವಾಗಿ ಇನ್ನ ಡಿಫರೆನ್ಸ್ ಮಾಡಕ್ ತಗೊಂತಾ ಇರೋದು ಅಂದ್ರೆ ಯಾವ ತರ ಬಾಂಡ್ ಉಂಟು ನಿಮ್ಮ adsorbate ಮತ್ತೆ adsorbent ಮಧ್ಯದಲ್ಲಿ. Of course, let us first of all deal with physical adsorption or your physisorption. Yes, remember guys, it is an adsorption process in which the accumulation of your gas on the solid. What is happening? It's a type of adsorption process where the accumulation of your gas on solid occurs through, this is important, weak van der Waals force. What is that? Weak van der Waals force. So that type of an adsorption is called as a physical adsorption or a physisorption. In simple words, if the bonding between that of your adsorbate and adsorbent is a weak van der Waals force, then that type of an adsorption will be called as what? Physical adsorption. Coming with respect to the chemical adsorption, how can you say? Okay, if you ask me, what sir, can you give me an example? Of course, I can give you whatever the part we have learnt earlier, chlorine gas which is getting adsorbed on charcoal. Chlorine gas which get adsorbs on your charcoal is a better example for your physical adsorption. Coming with respect to the chemical adsorption or chemisorption, what you can say? So mainly the gas molecules are held on the surface of the solid, by strong chemical bonds. It could be any type of your chemical bond, but majorly we'll be seeing it will be of type of your covalent bond. Okay, so what is happening? The interaction or the bonding between that of your adsorbate and adsorbent is a strong chemical bond. Then that type of an adsorption is called as what? Chemical adsorption. If you ask me the example for this, of course we can say that it is your hydrogen atoms. What is that? Your hydrogen atoms which are held on the surface of your nickel. So this here what is happening? The nickel is strongly bonding your hydrogen atoms by a strong chemical bond. Once they get fixed, it is very hard to break. So hydrogen atom which gets adsorbed on the nickel is a form of your chemical adsorption. Other way, if you say for chlorine gas adsorbs on the charcoal, it is an example of your physical adsorption or a physisorption. So both the types of the adsorption, main distinguishing we are taking that what type of the bonding is existing between that of your adsorbate and that of your adsorbent. But the main important thing further we have to read about the types is we have to understand what are the main characteristics of the particular adsorption. So first and the foremost thing, let us understand what are the characteristics of your physisorption or physical adsorption. Of course, we know what our adsorption is a spontaneous process. But whenever it is occurring spontaneously, now the question arises that whether they are specific in nature or whether they are non-specific in nature. In simple words, we could just say that if an individual is there, someone likes eclairs chocolate, so someone like Mentos, alva. But it depends. If this individual, whether he likes eclairs or Mentos, it depends. So it is what? It's highly specific for this individual that if he doesn't like Mentos means what? It is highly specific to eclairs. But there will be some individuals like me who will like both the chocolates. That means what? He is not specific. He is only specific that he likes chocolates, but he is not specific that what kind of the chocolates he need. But in the first scenario, of course he likes chocolate, but in that he is specific. Liking of a chocolate is a spontaneous process. In that spontaneity, to be specific, we are going to understand their characteristics. Do remember, in characteristics of physisorption, remember the first important thing is it lacks specificity. It lacks specificity. That means what? Any gas or the liquid molecules can get adsorbed on the surface of any solid. Any gas or that of your liquid molecules can get adsorbed on the surface of any solid. That means what we can say in simple words, they are not having any specificity. Which one? Your physical adsorption is not having any specificity. You can ask me, why sir? Because there we have to understand what type of a bond is existing. Remember, your van der Waals force is a universal force. So due to its nature of the bonding, we can easily say that any solid surface can adsorb any of your adsorbate. That is the reason we say as what your physical adsorption is lacking the specificity, or it is not highly specific. Coming with respect to the next characteristic is with respect to that of your nature of adsorbate. Nature of adsorbate. Of course, we came to know with respect to the specificity that any molecules can get adsorbed on the surface of this solid. But now the question arises, how much adsorption takes place? Or in simple words, what would be the extent of adsorption? Whether the extent of the adsorption is 100% or whether it is 50%? Yes, in order to understand that one, we have to understand what is the nature of your adsorbate. So before going to this nature of the adsorbate, we have to understand a concept called as that of your critical temperature. What is that? Critical temperature. Can anybody define this critical temperature? Yes? Yeah. So it is the temperature, it is the temperature at which or above which a gas cannot be liquefied. A gas cannot be liquefied. Alva, the temperature at which or above which a gas cannot be liquefied. So such temperature will be called as what? Critical temperature. For each and every gas there is a critical temperature. Why did I say this? Because whatever your molecules which are getting adsorbed, if it is a gas, it mainly depends upon its critical temperature. How does it depends? It is mainly depending upon this fact. What is that fact? Higher the critical temperature, remember, higher the critical temperature, what happens? Higher is the rate of adsorption. Higher is the rate of adsorption. ಕ್ರಿಟಿಕಲ್ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಇದ್ದಷ್ಟು ಏನಾಗುತ್ತೆ, ನಿಮ್ಮ ಅಡ್ಸಾರ್ಪ್ಷನ್ ರೇಟ್ ಕೂಡ ಜಾಸ್ತಿ ಇರುತ್ತೆ. Now the question arises, why I am saying so? Of course, what did I say? Whenever you take a solid surface, yes, the molecules which are on the top, they are having some residual force. That is the reason what they are doing. They will try to absorb the liquid or that of your gas surface. We know what during the condensation process, yes, condensation means what? The gas molecules should come together. Gas molecules comes together and then they form somewhat water. Or they will be forming a liquid state. ಈಗ ಏನಾಗ್ತಾ ಉಂಟು, ಕ್ರಿಟಿಕಲ್ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, of course the molecules comes and sits over here on the surface of this solid. So critical temperature ಜಾಸ್ತಿ ಇದ್ದಷ್ಟು we have the time to accumulate these gas molecules on the surface of this solid ಅಲ್ವಾ. ಅವಾಗ ಏನಾಗುತ್ತೆ, once they are getting ಏನಾಗ್ಬಿಡುತ್ತೆ, they try to condense and they try to bind your solid surface very tightly. But in case if the critical temperature itself is less, you just make a knowledge of that. If the critical temperature itself is less, it will be not be possible for the molecules to come together. Or in simple words, they cannot be liquefied easily. Alva? Critical temperature ಜಾಸ್ತಿ ಇದ್ದಷ್ಟು ಏನಾಗುತ್ತೆ, ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಹತ್ರ ಬರೋದಕ್ಕೆ ನಮಗೆ ಒಂದು ಮೀನ್ಸ್ ಮಾಡಿಕೊಡುತ್ತೆ, ಒಂದು ದಾರಿ ಮಾಡಿಕೊಡುತ್ತೆ. ಸೊ ಅದು ಹತ್ರ ಬಂದಷ್ಟು ಏನಾಗುತ್ತೆ, ದ ಗ್ಯಾಸ್ ಗೆಟ್ಸ್ ಲಿಕ್ವಿಫೈಡ್ ಈಸಿಲಿ ಅಂಡ್ ದೇ ಗೆಟ್ ಬೈಂಡ್ ಟು ದಿ ಸರ್ಫೇಸ್. ಬಟ್ ಒನ್ಸ್ ದ ಕ್ರಿಟಿಕಲ್ ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸಸ್, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, this gas molecules cannot be liquefied even whatever the pressure you may apply. So they will try, even you will try to make them sit on the surface. Due to its highly randomness motion, they once again gets dissolved. ಅಲ್ವಾ, ಡಿಸಾರ್ಪ್ಷನ್ ಆಗ್ಬಿಡುತ್ತೆ. ಆ ರೀತಿಯಿಂದ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಕ್ರಿಟಿಕಲ್ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಇದ್ದಷ್ಟು ಏನಾಗುತ್ತೆ, ರೇಟ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ವಿಲ್ ಬಿ more. It is similar to like your examination hall. Yes, 40 students are there and you're writing an exam. If one teacher is there, what happens? Of course, you will try to copy. Alva? If the number of the teachers increases, what happens? The rate of the copying goes on decreases. Alva? That will you will be remain much strict. The same way, if I take the number of the teachers as that of your critical temperature, yes, the strictness, what happens? It goes on increases. So if I take the strictness, my strictness as that of your adsorption rate, as the number of the teachers increases, the strictness increases. Similarly, as the critical temperature increases, the extent of the adsorption also increases. The same scenario. But in science way, if you have to understand, you have to understand by this way. As the critical temperature increases, what happens? With the application of the pressure, the gas can get liquefied easily. That means what? Molecules can come together easily. We know that what? When the adsorption process takes place, the randomness is decreasing. Alva? That is only possible when if the gas molecules are having the higher critical temperature. In case if they are having the lower critical temperature, means what happens? They will try to get dissolved. ಏನ್ ಅಡ್ಸಾರ್ಬ್ ಆಗಿರುತ್ತೆ ಅದು ವಾಪಸ್ ಏನಾಗುತ್ತೆ, ಡಿಸಾರ್ಪ್ಷನ್ ಆಗುತ್ತೆ. ಆ ರೀಸನ್ ಇಂದ ನಾವೇನ್ ಹೇಳ್ತೀವಿ, ಈಸಿಲಿ ಲಿಕ್ವಿಫೈಯಬಲ್ ಗ್ಯಾಸಸ್. ವಾಟ್ ಇಸ್ ದಟ್? ಈಸಿಲಿ ಲಿಕ್ವಿಫೈಯಬಲ್ ಗ್ಯಾಸಸ್ ಕ್ಯಾನ್ ಗೆಟ್ ಅಡ್ಸಾರ್ಬ್ಡ್ easily, or they get readily adsorbed due to the stronger van der Waals forces near your critical temperature. But why we are choosing your easily liquefiable gas? Because it depends upon your critical temperature. Higher the critical temperature, of course what happens? Higher will be the rate of adsorption. So this is the main characteristic one has to know in the concept of your nature of the adsorbent. That easily liquefiable gases can get adsorbed easily. Higher the critical temperature of your gas, higher will be the rate of adsorption. Of course, I think I have given you an exercise over there. What I have given, if you have taken a 1 gram of your activated charcoal, yes, which one among the following gas, I hope I have given as SO2, and here you have CH4 methane and that of your H2. Nearly SO2 has a critical temperature, near values I am writing. Nearly it has a 600 Kelvin, CH4 is having nearly 200 Kelvin, and that of your hydrogen nearly I think 32 or 33 Kelvin. Alva. So among this one, yes, all whatever the temperature they have given is the critical temperature. So which one among these three gases the adsorption rate will be more? You're having 3 seconds. Yes, it is your SO2. Why is it so? Because it is the gas which is having the higher critical temperature. So once it is having the higher critical temperature, and the artha enu, they can come and sit on the surface of the solid at a greater rate. So when that such a greater rate is existing, what happens to the rate of the adsorption? It also increases. So among the three gases, your SO2 will be having the higher rate of adsorption. Yes. Coming to the another characteristic, now let us see. It is with respect to your reversible nature. Reversible nature. Yes. Please do remember, as I have mentioned, whatever the van der Waals force is there is a weak van der Waals force. Alva. So easily we can break it. So when such easy breakage is possible, what happens? Easily we can say that your physical adsorption of adsorption is reversible in nature. Is what? Reversible in nature. In simple words, we can say whenever a reversible concept comes, you have to keep in your mind, it follows what? Which principle? Yes, Le Chatelier principle. Le Chatelier's principle. Please do remember your physical adsorption what? Is a reversible in nature. This reversible nature is why? Because the bond which exists is a weak van der Waals force. Next, the most important thing we have to remember, and it is an important characteristic in both type of the adsorption, is called as that of your surface area of adsorbent. What is that? Surface area of adsorbent. Now my question is to you that what did I say? Of course, whatever the adsorption is taking place is because of the molecules which are present on the surface. Alva. Consider now this is like a rod. Yes, like this you have taken a rod. There are some molecules which are present in the middle also and also at the end part. Of course, this is also a surface, this is also a surface, this is also a surface, this is also a surface. Only these molecules will be in the middle part. Alva. Of course, all over the molecules which are at the surface, they are having some residual force. Now my question is, if this was one rod, okay, now I am going to make this rod like a powder. What I am doing, I am trying to make this rod like a powder, and of course this same rod has been made a powder and it has been covered on the, and I am spreading it on the I am spreading it. This was also 1 gram of rod. I have broken it, I have made it as a powder and I have spread it on some surface. Now my question is to you is whether the extent of adsorption on this rod is more, or whether the extension of the adsorption on this powdered surface is more. What will be your answer? Of course, the hint is what? Greater the number of the molecules on the surface, extent of the adsorption will be more, because they will be acting as what? Active centers. They will be having more and more residual force. If your answer is that, if I consider this one is A and this one is B, among A and B, which one is having the higher rate of adsorption? If your answer is B, well and good, because you have understood the concept of adsorption. If you have not understood, now let me make you understand. Of course, you just consider you are having your 3 layers. Alva, you are having your 3 layers. This is 1 layer, this is 2nd layer, this is your 3rd layer. Alva. So among these 3 layers, yes, your first layer can adsorb and your 2nd layer can adsorb, because they are what? Are on the surface of your solid. But when I am making this rod as that of your powder and I'm spreading it, what has happened? These layers are now first layer. If I consider this one is first layer, yes. Where will be your second layer will be? Of course, that will come on the surface. Alva. Of course, now third layer where it will be? It will also come on the surface. So what happens? All the three layers are coming on the surface when you are increasing the surface area. Alva. So as the surface area increases, what happens? Extent of the adsorption increases. That is the reason we say that your finely divided metals and that of your porous substances. Porous means which is having an active centers. Porous substances have large surface areas. And they are good adsorbents. If the question you ask me why, here is your answer. When you take it as a bulk material, what happens? Of course, any of the layers which is on the surface will only capable to absorb the adsorbate. But when you make them as a finely divided material or a finely powdered material, what happens? Of course, the surface area increases. Of course, here you can see, here just this much is your surface area. But here at what happens, it has been doubled. That is one thing. Of course, when the surface area increases, what happens? Whatever the molecules which were present inside that of your bulk material will also be exposed to the surface. So once the molecule gets exposed to the surface, what happens? They will be having the residual force, higher residual force. So in order to balance that higher residual force, what happens? Higher will be the rate of your adsorption. That is the reason when considered with respect to the bulk material and that of your finely porous material or a powdered material, your powdered material will be having the higher rate of the adsorption, and the main reason is because of the increase in the surface area of your adsorbent. Is that clear? Yes. So as the surface area of the adsorbent goes on increases, what happens? The extent of the adsorption also increases. So in case if they will ask you a question that among finely divided metal and that of your bulk metal, which is a good adsorbent, your answer should be finely divided metal. Because in that finely divided metal, you will be having the higher active sites. So as the number of the active sites increases, what happens? The extent of the adsorption also increases. Coming to the another characteristic, it is called as what? Your enthalpy of adsorption. Enthalpy of adsorption. Of course, we know what adsorption is an exothermic process. Alva. But in that exothermic also, you do remember your physical adsorption or physisorption, the enthalpy of adsorption is low compared to that of your chemical adsorption. Of course, why? Because it is mainly because of your weak van der Waals force. So what type of a bond is existing in a physical adsorption is a weak van der Waals force. That is the reason whatever the amount of the energy which is getting liberated, it is also low. But of course, the energy is liberated. But how much energy is liberated? That is comparatively low when you are comparing it with that of your chemical adsorption. So what are the things we have learned? Is first and the foremost thing we have learned is that of its specificity. We came to know that your physical adsorption is not specific in nature. Secondly, we saw with respect to the nature of the adsorbent that easily liquefiable gas can get easily adsorbed on the top of your surface of the solid. And in among that one, we also studied higher the critical temperature, higher will be the rate of your adsorption. Coming to another characteristic is with respect to the reversible nature. What we have studied over here, of course, your physical adsorption is reversible in nature. That is, it follows a Lee-Chatelier principle. Coming with respect to the surface area of the adsorbent, of course, as the surface area increases, your rate of the adsorption also increases. And the last part we also saw, it was with respect to the enthalpy of adsorption. What did it say? Of course, the physical adsorption is exothermic in nature, but the enthalpy of adsorption is low, mainly due to its weak van der Waals forces. Okay. Now we will be seeing another characteristic of your, we can say the characteristics of your chemical adsorption, or what is also called as what? Chemisorption. So in this one, of course, the first and the foremost thing we will be studying with respect to is specificity. Specificity. Do remember your chemical adsorption is highly specific in nature. Highly specific in nature. Of course, its specificity is mainly coming with respect to the aspect of its chemical bond. That is, the bond is formed between that of your adsorbate and adsorbent is a strong chemical bond. And we know what? A chemical bond has to form means what? The two reactant has to react with each other. Alva? The same scenario is over here. Since whatever the bond which is existing in that of your chemical adsorption is a chemical bond, we have to keep in our mind that the reaction is highly specific in nature. Yes. It is mainly because we know that if two molecules A plus B has to give rise to C means what? This A plus B has to form a chemical bond between them. And in order to form such a chemical bond, what should be? A should be reacting with B. That is, these two reactants should be highly specific. That is the reason we say as what? Your chemical adsorption is highly specific in nature. For example, if you take whatever your hydrogen molecule is there, that only adsorbs on your transition metals. It only adsorbs on what? Your transition metals. Alva? Why is it so? Because hydrogen has only the capacity to react with that of your transition metals. That is the reason it falls under that of your chemical adsorption, which is highly specific in nature. Coming to the another aspect, it is called as what? Your reversibility. Basically, you have to remember it is irreversible in nature. Your chemical adsorption is irreversible in nature. It is once again because of the chemical bond. We know that whatever the chemical bond will be formed, it is very strong in nature. And in order to break it, it is not that much simple. That is the reason we say as what? Your chemical adsorption is irreversible in nature. Coming to the another aspect, it is with respect to its surface area. Of course, I have mentioned this is one of the important type. Remember, in both your physical adsorption and chemical adsorption, you have to remember that as the surface area increases, what happens? The rate of your adsorption also increases. Rate of the adsorption also increases. I have explained it over here itself. Of course, the layer which was at the center will also get exposed to the surface. So as the number of the molecules which are having the residual force increases, what happens? Of course, the extent of the adsorption also increases. The same concept is over here. As the surface area of the adsorbent, increases, what happens? The rate of the adsorption also increases. Then coming to the fourth characteristic, it is also, of course, it is called as what? Enthalpy of adsorption. Enthalpy of adsorption. Of course, what we can say, since the bond formed is what? Is a chemical bond, alva? So chemical bond namko ಏನಂತ, it is highly stable. ಒಂದು ಬಾಂಡ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಆ ಮಾಲಿಕ್ಯೂಲ್ ಏನಾಗಿರುತ್ತೆ? ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. ಸ್ಟೇಬಲ್ ಆಗಿರಬೇಕು ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಎನರ್ಜಿ ಲಿಬರೇಟ್ ಆಗಿರಬೇಕು. Energy liberate ಆಗಬೇಕು ಅರ್ಥ ಏನು? Higher the energy liberated, what happens? Stability will be more. So what we can say with the enthalpy of adsorption? Of course, it is very high. So enthalpy of adsorption for that of your chemical adsorption is very high, since it favors what? Chemical bond formation. ಅಲ್ವಾ? ಕೆಮಿಕಲ್ ಬಾಂಡ್ ಆಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಸ್ಟೇಬಲ್ ಆಗ್ತಾ ಉಂಟು. ಸ್ಟೇಬಲ್ ಆಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಎನರ್ಜಿ ಜಾಸ್ತಿ ಬಿಟ್ಕೊಡ್ತಾ ಉಂಟು. So that is the reason we say as what? Enthalpy of adsorption for your chemisorption is very high. So these are the two important, you can say these are the important characteristics of your chemical adsorption and physical adsorption. But the major important and what you can say a characteristic which is existing in both is the surface area of the adsorbent. As the surface area increases, the extent of the adsorption also increases. So this were the two important types of the adsorption and some of their important characteristics which makes us to distinguish that what type of an adsorption is taking place, whether it is a physical adsorption or whether it is a chemical adsorption. Okay, so this is very much important because sometimes in exams they can ask you to distinguish between the two. Yes, you have to remember that chemical adsorption and physical adsorption basically you have to remember what are the things, that how they are specific in nature and how, what you can say, how the surface area going to influence the rate of the adsorption and what are the enthalpy of adsorption, whether they are reversible in nature or whether they are irreversible in nature. Of course, there one more characteristic is going to come in these two types of the adsorption, which I am going to explain when I am dealing the effect on the pressure, effect of pressure on the rate of the adsorption. Yes, and there we will be seeing another important characteristic. Till then, you understand this video. In our next video, we are going to see the effect of pressure on the rate of an adsorption by an equation which is called as Freundlich adsorption isotherm. What is that? Freundlich adsorption isotherm.